All right, ladies and gentlemen, good morning. So the title of the lesson is called Adding and Subtracting Polynomials. Okay, so we're going to do 4 examples, and then I'm going to give you guys 2 problems to try on your own. And then you can always pause the video and try them out before I show the solution. Okay, so let's begin with example number 1. Go ahead and copy it down. Pause the video whenever you need to. Okay, so the key in adding and subtracting polynomials is to look for the like terms and add their coefficients. Okay, we're going to be doing a series of addition and subtraction. So these 2 problems are exactly the same except for the operation in between the 2 polynomials. Okay, so let's begin with the first one. What I'm going to do is I'm going to look for the first like term that has the highest degree. So in this case, x to the 3rd power. So I look in this first polynomial, I don't see any other x to the 3rd powers. So that's the only one there. And then over here, there's only one there as well. So it's going to be 2x cubed plus 1x cubed. Notice there's no 1 written there, but it's implied because there's only 1 x cubed there. Right here, there's an x squared, but there's 6 of them. Okay? And then the ones without a variable are called constants. So 2x cubed plus x cubed plus 1x cubed is 3x cubed. And notice I underlined the like terms once here. Okay? Let's move on to the next highest degree. So the x to the 3rd was the highest one. The next one would be x to the 2nd power. So here I have negative 5x squared. And then there's another x squared here is a positive 6x squared. So this will be underlined twice because those are the like terms. And by the way, you can use a square around it or a circle or a triangle, however you want to separate the like terms. So here we have a negative 5 and a positive 6, and they're being added together. Okay, so what we need to do is combine these. And so since I have 6 positive x squares here and 5 negative x squares, I'm going to go ahead and subtract these. So 6 minus 5 is 1. So I'm going to go ahead and write 1 x squared, or just plus x squared. Again, without writing the 1, I am already implying that there's only 1 there. Next like term are the x's, right? So x, there's 1 3x here, but when I look over here, there isn't any term that has just the x variable. So that means this has no like terms. I just bring it down into my answer. Okay? And notice here the last 2 terms here are just constants because they have no variables. So I go ahead and look at this one. This is a negative 9. I'm going to go ahead and underline it 4 times because I'm going here in increasing order. So we have 4 and then 4 underlines under those. Those are the like terms. So negative 9 plus 11 is going to be 2 because there are more positives than negatives. And so 11 minus 9 is 2. And I give it one last look to make sure I didn't skip any, and I already know I didn't, so this is my final answer. This is the simplified answer of these 2 polynomials added together. Okay? And if you have any questions, you can ask it during the live session that we have. Next example. Notice here I have the same polynomials, but this time they're going to be subtracted. Whenever you have subtraction in between 2 polynomials, you have to do one extra step. And what that means is you're going to have to distribute the negative here. Now think of this as a negative 1 in front of the polynomial. So I need to distribute to each term inside. I need to go ahead and distribute the negative 1. So let's go ahead and do that first. Negative 1 times x cubed is going to be negative 1x cubed. Again, I don't have to write the 1 there. Negative 1 times positive 6x squared is going to be positive, oops, made a mistake already. Negative times a positive is going to be a negative 6x squared. And then finally, a negative 1 times 11 is going to be a negative 11. Okay? Now, I'm going to go ahead and bring down the first polynomial just as is. I haven't done anything to it. I'm just going to bring it down without any changes. Okay? Now, you can think of this as 2 polynomials again being added, okay? Or I could have just left it as it was there, and just go ahead and combine the like terms. So let's go ahead and combine the like terms. So I have x cubed here. So I'm going to underline that once and underline this one once. So 2 minus 1 is 1. So this is going to just be x cubed. Because 2 minus 1 is 1, so I have 1x cubed there. If you'd like, you can slash them out so you know which ones you've already used. Okay? Next, I have the x squares. And so I have negative 5x squared, and then I have negative 6x squared. Notice in the problem above, I had a positive 6x squared and a negative 5x squared, so we subtracted. In this case, we have two negatives, a negative 5 and a negative 6. So we have negative 5 and negative 6. That means we're going to have a total of negative 11x squared. So we add those two negatives because they are the same sign. Next, we have positive 3x. Remember, there's no other x term there, so we just bring it down. I'm going to go ahead and slash these here. And then I'm left with negative 9 and negative 11. That's going to be another addition problem because I'm going to have more negatives. So I have a total of negative 20. And so that's my final answer. Notice the difference. Two different answers. One when we added and one when we subtracted. Okay? Next examples. So here again we have a trinomial. This is a polynomial plus another polynomial, okay? So let's go ahead and look for the highest degree. What I mean by highest degree is it has the highest exponent here. So here we have y to the third power, but there is no other y to the third power here. And I'm adding, so I don't need to distribute a negative all the way to the second polynomial. So I'm just going to go ahead and bring down the 3y to the third. I've used that one, so I don't need it anymore. Next are the y squares. So I'm going to go ahead and underline this one here twice. Okay, those are my like terms. Notice they're both negative, so I could go ahead and add them. So that's going to be negative 6y squared. Double check that there are no other y squares, and there aren't. So we're good. We're done with those. And then we move on to the y's. So we have negative 7y and then positive 2y. That's going to be negative 5y. Again, if I have a negative and then a positive over here, I'm going to go ahead and subtract those two. That means I'm going to end up with more negatives here. Okay, so negative 5y. So those are done with. And then finally, negative 5 has no other constant to combine it with, so just bring it down into the answer. And this is my final answer. Okay, one more to go, and then you guys will have your two problems to try on your own. So again, whenever you have a negative in between two polynomials, you want to distribute the negative one. There is an invisible one. You want to distribute it to the second polynomial. Okay, so let's go ahead, and I like to draw arrows here to indicate that I'm going to be distributing 3 times. So negative 1 times negative 4 is going to be a positive 4y squared. And then here a negative 1 times a positive 2 is going to be a negative 2y. And then a negative 1 times a negative 5 is going to be a positive 5. I'm going to bring down the other polynomial without its parentheses. And I'm just going to leave it like that. I'm not going to put parentheses around the first polynomial and then around the second one and put the plus sign in between. I'm just going to go ahead and leave it as one long list of polynomials written there. I'm just going to go ahead and combine like terms just like this. So again, I look for the highest degree. That would be the 3y cubed. There is no other like term with it, so I bring it down as is. Next, I have my y squared, so that's going to be that one and this one. So negative 2y squared and positive 4y squared is going to be positive 2y squared. Slash those, I don't need those anymore. I have negative 7y and negative 2y. That's going to be negative 9y. Again, if they're both negative, you add them together. If one's negative, one's positive, you subtract them and keep the sign of the larger integer. Okay. Next, we have, I'm going to cross those out, and then we have the positive 5. And so we bring that down, and that's my final answer. Okay. Compare the two answers notice they're completely different. Okay, they have the 3y cubed the same, but everything else is different. Okay. All right, so now you're gonna pause the video and you're gonna go ahead and try these two problems. Go ahead and click pause, copy the problems down, and give yourself about 2 minutes to complete both of these. Once you're done, I'll show you guys the next slide. So make sure you pause the video because I'm gonna move this paper away now. And here are the solutions. Okay? So notice here, what I did here is I simply combined like terms. I underlined the t squares once, I added them. I underlined the t terms, the negative 6t and the negative t. Notice how they were both negative, so I added them. And then I have 2 and negative 8, that makes negative 6. That one was quick. And the last one, 8d minus 3 plus 9d squared. Notice these are out of order. They're not in what we call standard form, which means that we have the highest degree first and then the constant at the end. So this one's mixed up. Okay, but it was a subtraction problem, so I went ahead and distributed the negative 1 all the way across. And then I combined my like terms below and I got my answer. So go ahead and pause the video, look through my worked out solution, and then go ahead and make sure that you got the same answers as I did. If there are any parts where you didn't get the same answer, go ahead and save that question for when we meet online, or maybe you can figure it out on your own. And that's today's lesson.